Hi. This is going to be the second of two moon phase videos. So we've seen last week in the lecture content online all about the seasons on Earth and how we experience those. We thought a little bit about the grid that we use on the sky, as well as how our calendar reflects actual astronomical motions. We also had a video that was the initial part of section 4.5 here, the phases and motions of the moon. And there's a deeper look video for the phases of the moon and the names of them and the order they go in that you should probably look at first before this video, but there'll still be a lot of useful content if you haven't had a chance to look at that one yet. So we have started this section and we're going to finish it here and think a little bit more about the order of moon phases and how we can actually think critically about when we would see them, where we would look to see them, and things like that. So the terms that we have introduced ourselves to in the previous video on moon phases and in the deeper look video are on this slide, mostly as a reminder of what we have already covered up until this point. And the things we talked about last week in that first video of moon phases are key ideas that we were able to puzzle out and think through, is that the moon is lit up because of reflected sunlight. It's not making its own light. There is no single dark side of the moon because the phase, the part of the moon that is lit up from our point of view is aimed at us or it isn't aimed at us. But if we were to stand on the moon, we would experience daytime and nighttime as the moon rotated. And although the moon is rotating, it rotates in such a way that there's always one side that is facing towards the Earth. That's the near side, and there's always the same side, there's always the same side of the moon that's facing outwards into space that can't see the Earth, and that's the far side. And those don't change because the moon is tidally locked to the Earth. So those are all the sort of key concepts that we took out of last video. And so now we're going to add to that. So a question for us to make sure that we're on track with this. This is now something that we should feel a lot more confident answering than the first time that we had this kind of question in the moon phase video section. So pause and think for us. I'll read the question and then I'll take a break so that you can pause the video to think through your answer. So which of the following best describes why the moon goes through phases? Okay. So option 1 here is that misconception that if we picked it, then we need to go back probably and watch those other videos, because that is something that we need to confront. When we've got these initial ideas that are incorrect, we have to actively confront those so that we can learn the correct content. Basically move that stuff out of our brain to make space for the correct ideas. Number 2, we should have ruled out right away through critical thinking. If I can go online and look up exactly what phase of the moon we're going to have on April 21st in the year 2027, then what it means is we have to have some way that we know really, really far forward in time what phase it's going to be. And we can barely predict the weather for tomorrow, let alone for next week. And so Earth's clouds playing a role somehow in moon phases can't possibly be the case because we're able to predict them so far in advance. Option 3 is a sort of new one compared to the first time that we had this question, and it's one that students sometimes fall for, so you may have fallen for it because it kind of sounds sciencey, right? But the sunlight that lights up the moon is not bouncing off of Earth and then lighting up the moon. The sunlight is directly hitting the moon and then bouncing towards our eyes so that we see it lit up. And so option 3 has the wrong idea, even though it's got a lot of words that seem like they should be reasonable. And so the last option here is different wording than the first time we had this question in the previous video. We only see part of the lit up half of the moon, the day side of the moon, based on where it is relative to our point of view and where it is relative to where the sun is. So this is going to be the time where we want to make note that we should try this lecture tutorial. If this is the online class, then working with this to talk through it with your classmates in the discussion boards. If this is an on-campus flipped classroom class, then these are going to be the ones that are coming up the next time that we meet. So the cause of moon phases we're going to want to go over, and in a separate forum, in a separate format, we'll go through the answers eventually so that you have those to be able to think about. So this question we should be able to answer after the lecture tutorial. So if you haven't done it and we're on the online version, then try that first before you answer these questions. So during the full moon phase, how much of the moon's surface is being illuminated by sunlight? So pause the video and read through the options and think about what you would pick. Okay. Now the wording here is specific. It's not caring about us on Earth looking at the moon. It's saying out of the entire surface of the moon, how much of it has sunlight falling on it. And that's always going to be half. Whether we're talking about the full moon, or whether we're talking about a waxing gibbous moon, or whether we're talking about the new moon, the answer to this kind of question, how much is illuminated by sunlight, will always be half. Okay, now before we continue on, I want to make sure that we have just a brief discussion of section 4.6 in the book, because we won't see it after this. There's a lot of ideas out there on the full moon causing people to act differently because the moon is pulling on the water in our bodies and all that sort of thing. And there's another easily disproved myth that more babies are born on the full moon than any other moon phase. And all of those aren't scientific hypotheses, because there's already enough evidence out there to prove them wrong. And there have actually been studies that look at birth records and what phase the moon was to see if there was any merit to that claim, and there isn't. The other thing that's worth noting is if anyone ever tells you something about how the full moon is because of tides and the way that gravity pulls, that somehow it's affecting us more. New moon has the same amount of pull when we take into account the pull of gravity from the sun and the pull of gravity from the moon. And so what I mean by this is there's an animation that we can look at. And I'll see if I can pull it up here. If not, there'll be a little jump in the video while I cut that part out. We've got this video, so we're going to run it. Excellent. So what this is showing is the moon. We don't have the sun at all, so the moon's not being lit up here. And we see Earth spinning around every single 24 hours every day. And a highly exaggerated version of what's happening with the water on Earth. So water can slosh around, and gravity's trying to pull the water towards the moon, but also on the opposite because of that sloshing idea. So high tide and low tide. When we include the pull of the sun, so now we've got phases of the moon. It's always half lit up from our point of view, but we've got those phases where if we look at that bulge from the water, it is much, much stronger at new moon when the pull of gravity from the moon is in this direction and the pull of gravity from the sun is in this direction. And so at this time of the month, high tide would be really, really high and low tide would be really, really low as the water sloshes around a lot. And then if we wait a week to get to first quarter moon and we look at what happens, now the pull of gravity from the moon is in one direction and the pull of gravity from the sun is in the other direction. And so the tides aren't as extreme. High tide isn't very high and low tide isn't very low. And so if we wait around for full moon, we see that same effect that we saw with the new moon, that we have really high tides, and that's where all of the stories come from. But it's important to recognize that if someone's got this idea in their head and you ask them, well, what about new moon? And they don't have any answer for you, then it's not based on any kind of science. It's just something that they've heard or something that they've picked up. Okay. So the only other thing that I'll note before we close this animation is that because the Earth is rotating much faster, 24 hours, than the moon goes around the Earth once a month, that the effects from gravity would have been perfectly aligned, but the Earth has rotated forward a little bit, and so that is one of the big reasons that over long periods of time, we've been able to have the moon tidally locked to the Earth, and eventually the Earth will tidally lock to the moon, far out in the future, where the Earth will have the same length of day as we have a month, and there'll always be one side of the Earth that can see the moon and one side of the Earth that cannot. Okay, so we'll get rid of this. The link will be in the PDF. Okay, so we've talked about why the moon has phases, and hopefully we start to have a better sense of that as we think through the different ways that we've seen that information. The other thing that we want to make sure we understand is the order of those phases. So we initially introduced those terms waxing and waning in the first video, but this is really where we're going to understand them a little bit better. So if we think back to this set of 4 example moon phases, new moon, first quarter, full moon, third quarter, then the term waxing happens whenever we're looking at an object that is getting more and more visibly illuminated. So from our point of view, more of what we can see is lit up. And so from new moon to first quarter, we're waxing, and the shape we would see is a crescent, so that's a waxing crescent. From first quarter to full moon, we're still getting more illuminated from our point of view, and so it's waxing, and this shape's going to be a gibbous, and so it's a waxing gibbous phase. So we're waxing for half of the month. And then from full moon to third quarter, we're waning. We're getting less illuminated from our point of view. And so we get a waning gibbous because it's still more than half lit up until it gets to third quarter. And then as we wrap around the set of phases back to new moon, we're waning still, and we'll have a waning crescent shape as we have a lot less of the moon actually lit up. Okay, so the moon phases, the animation I've got here, I'm not going to open it in this video, but it is something that you should look through and look over if you have the ability to open it. It doesn't open on all browsers. But it helps us understand the order and all of those different alignments between the moon and the Earth and the sun, and what we're seeing compared to where it is in its circle, in its circular orbit, mostly circular orbit. There's a lot of different diagrams that you'll come across if you're looking online, or if you're looking at the textbook, or if you look through our slides after this, and none of them are to scale. The different diagrams that we look at each have different sets of information. Some might seem like they're too overwhelming and we don't want to look at those if they're not helpful to us. Some of them might be not helpful because they don't have enough content, and then we don't want to spend time on those either. So we're showing as many different ones as we can to find something that clicks with you. So this particular diagram is showing the moon going around the Earth in terms of the angle that it makes from new moon. So new moon is 0 degrees away from new moon. And as we get up to 90 degrees, we get to first quarter. And so that's a phase angle of 90 degrees. And then we get around to full moon, that's 180 degrees, and continue through 270 and then back to 360 degrees or 0 again. And half of the moon phases are waxing. So the top half of this diagram is all of the phases that are getting more illuminated from our point of view. And half of it is waning. The bottom half is all of the phases that are getting less illuminated from our point of view. What we call a crescent isn't just that one spot that we keep drawing in this sort of upper right or bottom right corner of these different diagrams. But instead, crescent it could be a really thin crescent or a kind of chunky crescent or an almost half lit up crescent shape. Those each last for about a week. In the same kind of way that with our full calendar, we've got 4 special days: the summer solstice, the fall equinox, the winter solstice, the spring equinox. But we have all of the rest of the year, 361 other days that have to fit into 4 seasons. It's the same kind of concept here, that we've got 4 really special phases: new moon, first quarter, full moon, third quarter. And all of the rest of the days during the month have to fit in between those. And so not seasons anymore, but in those names, waxing crescent is a whole bunch of different shapes that fit into that quarter of the month. And waxing gibbous is a whole week's worth of shapes, and waning gibbous is a whole week's worth of shapes, and waning crescent. So that's something to keep in mind as we go along. The other thing is, this picture is from our textbook. There's 2 different ways that we draw the moon. On the circle itself that we're looking at an angle, so that's why it looks so oval. It's mostly a circular orbit. We're just looking at it on its side. All of the moons on the circle itself with the letters, all of those are drawn with the side that faces the sun is lit up because sunlight is falling on it. The side that's on the opposite from the sun is dark because it's nighttime on that part of the moon. That's the way the moon looks from space. If we were in our spacecraft looking at this whole system, that's what it would look like from space. Then the outer set of moons that are drawn here, those are the ones that are showing what we would see at that particular phase. So first quarter looks like a semicircle, half a circle, where the right side is lit up because the moon gets bright from right to left. That's something that if we are able to sort of think through what direction everything goes, it makes more sense. But it's also something that maybe we just put into our mental framework and have that as a thing that we think about. Then if we look around to third quarter, it's also a semicircle, but now the left side of it is lit up from our point of view on Earth. And the moon, as it gets bright from right to left, it's also getting dark from right to left. So an animation that you can interact with will help you with this, and there'll be a link to one in Blackboard. And any kind of video that walks you through that will be helpful too. And there's lots of resources that you can find online that I'll try to link to some of the key ones. So if we look at a moon phase calendar, so there's lots of different ways. This is one of the simplest ones to use. When we pull that up and we get a calendar that just each one of the different days is showing us what the moon looks like in our sky, then we might be able to get a sense of how long it takes to go from full moon back to full moon again. Now, we had this situation with the length of a day earlier on in this chapter last week, when we talked about the fact that the length of a day is 24 hours by our clocks, where that by definition is high noon to high noon, how long it takes us to go fully aligned with the sun, spinning around the Earth back to fully aligned with the sun, which is a little bit more than if we were talking about being aligned to some distant star. It's the same idea with the moon, where if we're talking about how long it takes for the moon to go once in a single circle relative to background stars, that only takes 27 days. But if we're thinking full moon to full moon, which is the kind of time period that makes more sense to us since we care about moon phases, then that's 29 and a half days. And it's close enough to a month that in our brains, really all we need to think of is the moon phases take one full month to go through, because it's close enough for our purposes. And if we break that 29 and a half days down into 4 segments, then it takes 7.4 days for each quarter of the cycle. And so we can just put a week into our brain, and that will be just as good for us. So from full moon to third quarter takes a week, from third quarter to new moon takes a week, and so on. So with that in mind, And if it's something that hasn't quite clicked or you want to spend some time thinking about it, just pause the video or rewind and listen to it a little bit more. But what I want you to do is to look at these two pictures. So I took both of these pictures back in 2015. And the one on the left is from October 17th of that year at 7 p.m. So the sun had set, and so we're seeing the moon in a crescent shape. And I want you to estimate, so rough guess, what day the right moon, the moon on the right of this slide would be. So pause the video and actually try to work yourself through it and write down a date before you continue. And then we'll talk ourselves through that. Okay. So the moon gets lit up from right to left. So we're seeing just a small portion of the phases. To answer this, we kind of had to know what phases we're looking at. On the left side of the screen, we're looking at a waxing crescent moon. It's lit up on the right side and is going to get more lit up as we go. And it's a crescent shape, we can see that. And the moon is still lit up on the right, and so it's getting closer to full moon on our right side of the picture. And so that's a gibbous shape that we're looking at. If we look at that shape, spend some time actually thinking about that shape, it is not possible to make that shape by having Earth's shadow fall on this. And so if we're still stuck with that misconception, just look at that shape and try to imagine what Earth's shadow could do to make that shape, because it's not possible with that gibbous. Okay, so we're looking at a waxing gibbous moon. It would be about a week later. So from October 17th for the first picture, and this one is October 23rd at about the same time of day. Okay, so a couple of questions for us to think about. Both of those pictures that I had on the previous slide, I took while I was in Italy. So I was on my honeymoon, and rather than looking at the slides, I was looking at the moon. You know, honeymoon, why not? All right, so what phase, October 23rd, 2015, would we have seen in Michigan? So that same day, I was in Italy and I took this picture. What phase would we have seen in Michigan? That's the first question I want you to think about once you pause the video. Make sure that you know the name of the moon phase. So I said it briefly, but make sure that we can think through it, and we'll go through those answers in just a bit. And then think about whether you've ever seen phases of the moon during the day, because both of these pictures, different phases in our set of phases, and both of them we see at nighttime. Okay, so pause the video and think through those questions. Okay. It's important for us to make sure we understand the difference between a day's worth of change and a month's worth of change. I took these photos in Italy at 7 p.m. In that time zone. As the Earth rotated, it's still this moon in roughly the same part of three-dimensional space. And so in Michigan, you would have seen this exact same moon, and it would look about that shape, and it would look in that same kind of part of the sky that I saw it when it ended up being 7 p.m. in Michigan's time zone. And that's part of what time zones are, is something where if it's happening for me at midnight local time, then that same object might still be in that same spot if we're talking about stars, things that aren't actually moving, for midnight for somebody else that same evening. This is a waxing gibbous phase. Gibbous should be straightforward for us by now because we're looking at the shape to figure that out. And then waxing is the slightly tougher one, that if we get it into our mental framework that the moon gets lit up from right to left and dark from right to left, then this would tell us that it's a waxing gibbous as it gets more lit up. And then in terms of whether we can see the moon during the day, sure, it's harder. So this is the same day. I still wasn't looking at any of the cool things in Italy. 2 hours earlier, so before sunset. And what we see is it's harder to see the moon against the bright blue background of sky, it's a lot easier to see the moon when the background is pitch black because it's lit up and it is much higher contrast. But absolutely you can still see the moon during the day. It's just harder, that's all. Not every moon phase is visible at any given single time of day. So like at 9 a.m., there's only part of the set of moon phases that you can see at some point in the sky. But it is possible to see the moon during the day. Half of the moon phases are up during the day. Okay, so a question for us. We want to not only think about the order of phases, but also be able to think about what time of day they're rising and setting and what time of day they're high in the sky. So let's think about this question here. We'll pause once I finish reading the question out. Where would we look to see the full moon when it starts to rise? This isn't meant to be a tricky question, but a lot of students get hung up on it. No matter what object we're talking about rising, the fact that it's coming into view means the Earth has rotated so that it's suddenly above our horizon, and that means it's going to show up in the eastern direction, somewhere in the eastern direction. Anything that is rising and setting rises somewhere in the east, whether it's northeast, due east, or southeast, and it will set somewhere in the west, whether it's northwest, due west, or southwest. So make sure that if we got stuck on that one or we didn't know what to do, that we keep in mind the bigger picture. Stuff is rising and setting simply because the Earth is rotating. But the more important question then is, where would we look to see the sun at that time? So same 4 options. So pause the video and think through that one. Where is the sun when the full moon is rising? Okay. So the full moon and the sun are in opposite directions from our point of view on the sky. And so if one is rising, the other is setting. As the full moon is rising, by definition, the sun has to be setting. Otherwise, it isn't a full moon. It's maybe a day or two away from being a full moon. So the sun would be on the western horizon, option 3 here for that second question. So this is where we want to try the lecture tutorial predicting moon phases. So if you're taking the online class, then you should try it before you continue on in this video. If you're taking the on-campus flipped classroom class, then make a note that this is one that's going to show up the next time that we meet. And there's the deeper look video for moon phases, the discussion board to help you out, lots of resources. And this is a slightly tougher lecture tutorial compared to the previous moon phase lecture tutorial, but it's trying to push us to make sure we understand a lot of these bigger ideas. Okay, so a question that we should answer once we've tried the lecture tutorial. So if you haven't yet, then you probably won't be able to think through this one too much. So we want to think about which of the following groups of moon phases could be seen above the horizon at 9 a.m. The easiest way to answer this is to try to draw on a piece of paper in front of you all of the moon phases, and then put a little stick figure person like we tried in the lecture tutorial, put them at 9 a.m. and figure out what would be above their horizon at that time. Okay, so if you've drawn that, and it's tough for me to walk us through this if we don't have the image in front of us. If we look at all of the available moon phases, we start at option 1. So third quarter, we would be able to see kind of high in the sky at 9 a.m. Waning crescent, we would certainly be able to see in the sky at 9 a.m. But waxing gibbous would be below our horizon if we walk ourselves through that stick figure kind of person. Option 2, new moon, although we can't see it, it would be above the horizon. Third quarter would be above the horizon. And waning gibbous, at least a couple of days worth of waning gibbous would be above the horizon, close to setting, but they would still be there at 9 a.m. So 2 seems reasonable to us. Option 3, waxing gibbous we can't see at 9 a.m. Full moon we cannot see at 9 a.m. The full moon's set at sunrise. And so we throw out option 3. Option 4 still has that waxing gibbous option, which we've ruled out. We can't see any of the waxing gibbous phases. That whole week's worth of phases will be below our horizon at 9 a.m. And then option 5 certainly isn't right. We should have thrown that one out right away because we already had a picture a couple of days ago, and you've probably at some point in your life have seen the moon during the daytime. And if not, start to pay attention to it. The more that you're aware of it, the more you'll be able to see it. And so our only reasonable option here is 2. This slide, if it's helpful to you, is there to look back at in the posted slides. There's a lot going on with it. It's not in our current textbook. It's in a textbook we used to use. But what it's showing is all of the possible phases that you can see if you were to face south and take a picture at sunset. Some of the phases won't be visible if you're looking south at sunset. So, for example, we can see the first quarter moon is really, really high in the sky at sunset. It means that the third quarter moon is as far as it can get below our horizon. If instead of being a first quarter moon, we were 2 weeks later and the third quarter moon was the current phase. What that means then is if we want to try to take pictures of all of the other moon phases, we'd have to get up at sunrise and take that picture once every single day and try to see if we can see the moon or not. And so we catch all of the other possibilities once we're 12 hours separate. And here at sunrise, the third quarter moon is highest in the sky. It rose at midnight and it will set at noon. So if this pair of slides is helpful to us, excellent. If not, then never look at them again. Not a big deal. Another different way that students have found to be useful when we're trying to think about the different times of day that moon phases rise and set is just focusing in on those key 4 special alignments: new moon, first quarter, full moon, and third quarter. And make sure we understand that they rise at different times because the alignment is different. That means they're highest in the sky at different times. And then they'll set at different times. And each one of those is going to be about 6 hours separate. So from rise to being highest in the sky, in the southern sky, will take about 6 hours. And to go from being high in the southern sky to setting will take about 6 hours. It will change over the course of the year to the way that the sun does. But in our sort of overview, that's a good way to think about that. So, if we think back to the start of the previous video for moon phases, we had that initial question of what causes the moon to have phases. The correct answer, and hopefully after the set of videos we've had and the set of resources that we've looked at and the lecture tutorials we've done, hopefully we have a better sense of the actual reason why option 3 was correct, the various alignments. Because we want to make sure that we understand that more than just that statement. In the same way that for seasons, we wanted to understand far more than just that statement that the Earth's tilt causes the seasons. There's a lot more complexity and depth to that than just that single statement. So same here with the moon phases. There's a lot of complexity and depth to what we mean by various alignments and what that actually looks like and how we can make predictions of what we should see 2 days from now, 8 days from now, 20 days from now. And for those of you who voted option 2 originally, and I mentioned this in that previous video, there is an astronomical event that deals with the Earth's shadow. It just isn't the monthly moon phases. Instead, it's a lunar eclipse, and that's our next topic. And so we'll see that in the next video. If you still have questions on moon phases, you can always go through the resources that we have or ask those questions in the discussion board or in office hours. And otherwise, we'll move on to the next topic in the next video.